I'm Joshua Bardwell, and you're going to learn something today. I got a build video for you today, folks. Whole quadcopter, start to finish, one video. But it's not just any build video. This is a pretty special one for me. When I sit down to build, a lot of the time, most of the time, I'm not building the parts that I would build for myself. I'm building whatever I need to review this week. And that's cool. It means I get to try a whole lot of different stuff. But it also means that I'm almost never flying the exact quadcopter that I would like to be flying right now. I'm flying a hodgepodge of whatever the last 5 things I reviewed was. But that changes today. I decided I was going to treat myself and build the exact quadcopter that I want with the exact parts that I want, exactly how I want it. No compromises. And that's what we're going to see today. Stay tuned. Before I show you how to build the quadcopter, let's just take a, oh my God, take a look at it. Is that not beautiful? They're so pretty when you haven't flown them and gotten grass and dirt all over them, and that almost makes me not want to fly it, but I'm going to fly it. What did I choose to put in this build? The frame, of course, is the Chameleon Ti. It's been my favorite frame for a while, but the Rotor Riot episode where we smashed these guys through glass windows and sometimes missed the glass window and smashed into a brick at full speed or a metal car wheel, and just the frame just took a beating and came back for more. It really cemented my decision to stick with the Chameleon Ti as my favorite frame. The camera is the Bardwell / Rotor Riot Micro Eagle. This remains my favorite camera, even though Runcam and Foxeer have released some new cameras with very good image quality. The specific combination of great image detail and excellent dynamic range and excellent low light sensitivity means that this is still my favorite camera to put on a quad, period. The motors, of course, are my own Luminaire JB2407 2500 kV, and in addition to just having awesome colors, they fly pretty good. They're smooth. The large stator means they can be paired with even a heavier prop like a 5x4.8 without compromising handling, and the amp draw is not as bad as you would think. It's reasonable. It's a little hard for you to see it under there, but the ESC is the JB 4-in-1 ESC. And some people are going to be a little bit surprised to hear that I'm using a 30 amp ESC, especially on a build with these larger motors. I get that question a lot. How big of an ESC do you need? And I like to say this. A 30 amp ESC, that means that if you've got 4 motors, you can pull 120 amps continuous. If you've got a rig that's going to pull more than 120 amps continuous, then you should think about a higher rated ESC. But for most 5-inch setups, you're just not going to be pulling more than 130 amps, even if you're running. Your battery isn't going to be able to output 120 amps for very long. So I think 30 amps is fine for almost any 5-inch build. Go into a higher output ESC, like a 35, 40 amp. That'll give you a little bit more headroom against sort of popping the ESC in a voltage spike. Or if you're doing just a really high output build that's exceeding 120 amps for very long, maybe. But 30 amps is fine for almost any 5-inch setup. Frankly, 25 amps is fine for most 5-inch setups. Now, you'd probably expect on this build that I would use my own flight controller, and I didn't. And here's why. The flight controller that I did use is the Holybro Kakute F7. One reason I went with that is that I wanted to use an F7 because I kind of wanted this to be just a no-holds-barred, and F7 is more than F4. I also wanted as many UARTs as possible. The JB F4 can do SmartPort, S-Bus, and then have 2 UARTs spare and a 3rd UART if you use soft serial. And that's more than enough for almost any setup. But I knew that I was going to be using Crossfire on this rig, which means that I would lose 1 UART, and that means that I would have to really jump through some hoops on the JB F4 to get I didn't want to hold back. I wanted to do camera control, GPS potentially. I just wanted to have all the options possible, and the JB F4 didn't give that to me. So the Holybro Kakute F7 is the flight controller that I'm using on this build. The VTX is the TBS Unify HV. Just no question that this is one of the best VTXs you can get on the market. And especially with the Chameleon, I wanted to have it be as thin as possible, especially because of the way I mount my antenna on the Chameleon. It kind of takes up some space on the inside here. So VTX HV, it is the UFL version, which may surprise some people given how much I complained about the UFL on the Unify and begged for them to make an MMCX. Now that they've made an MMCX version, I'm using the UFL. Haha, joke's on you. One of the things they did, it's a little hard to show here, but they actually have some screws holding down the UFL. There, you can see them right there. So there's screws and a little metal tab holding down the UFL to keep it from popping off, and that certainly is nice. The receiver is the Crossfire Nano. I'm not using the new Crossfire Nano Diversity. I feel like for a typical freestyle quad with 5 gigahertz video, I'm never at below 98% link quality anyway, so I don't really feel like I need diversity for this kind of build. And the antenna that I'm using is the Ready-Made RC Hoot antenna. I love this antenna. It's a Lindenblad design similar to the Triumph, so it's pretty decent design. It's not the best in terms of RF performance, but this is just a super durable antenna. And in addition to the antenna itself being durable, whatever coax they're using here, it's really good at getting bent without actually wearing out and breaking as many of them do. So right here, I've got the ViFly FInder V2. That is a lost model buzzer, similar to the Hellgate buzzer you may be familiar with. If the battery ejects, then this has its own little one-cell LiPo, and it'll just start beeping. And even if your battery ejects, you can find your quad wherever it's gone down. I've chosen the ViFly FInder V2 instead of the Hellgate for 2 reasons. One is it's way freaking louder. It's super loud compared to the Hellgate. It's also a lot bigger, so if you have a really tight build, you may want to use the Hellgate instead. It also doesn't last as long. The Hellgate's quieter, but it'll beep it has a special algorithm where it slows down the beeping as the battery gets lower. So the Hellgate has its advantages, but I'm using the ViFly here. The other reason I've gone with the ViFly is that it has a button you can press. Normally you stop or disarm the buzzer by plugging in the battery for a few seconds and unplugging it quickly, and then that turns the buzzer off. But if the buzzer breaks off of the quad, or you're working it on a bench or something, I was at this event where people had Hellgates and it would get disconnected and then it would start beeping, and it would just sit there beeping and chirping forever because nobody had a battery hooked up to it to turn it off. So having the button as a backup is really nice. I really like the ViFly for that reason. The other accessory, and I really didn't think I was going to like these as much as I did, but I freaking love them. The other accessory I've got here, this is race wire. This is from CLRacing. It makes this particular one, and it's got LEDs on top. And yeah, I know there's a lot of people who make these. I just happen to go with these because the CLRacing ones come in purple. When purple is one of my colors that I like, so I got them. One of the cool things about these is they don't just look good, they're functional. It's really cool that you can actually see the individual poles lighting up. So when you plug in, if you've got a bad ESC, you'll see 3 of your motors and the race wire will light and the 4th one won't. And that'll tell you, if you're ever wondering, did I fry an ESC in that last crash or something? So it's pretty cool to see them for diagnostic purposes, not just, they also just look nice. I am using Grip here as the battery pad. The Chameleon Ti comes with a foam battery pad, but it's kind of squishy and compressible and not that sticky. Grip is really good for retaining the battery in a crash. I also use double battery straps, but it's very good. It also is just firm enough that the battery will not be able to come down and sort of damage itself on the screws. So got a little bit of Grip here. Those are the parts that are in this build, and now I'm going to show you the build video. And it's the whole thing. I'm not going to break it up into parts. I'm just going to let you watch the whole thing as much as you want. I will point out that if you go down in the video description, all of the parts that I've used here are linked. And if you want to do this build yourself, this is a hell of a good quadcopter. If I do say so myself, it's a really good flying quad, and I'm very, very happy with it. So if you'd like to build this, there are links down in the video description to all the parts. They're affiliate links, of course, and you really help me out if you use those. The way I'd like to approach this build video is not in a sort of hand-holdy step-by-step, but in a little bit more of a slower and more reflective manner. I did not record any voiceover while I was doing the build. I just wanted to kind of get the build done. And then I'm going to come back now and give you my thoughts as we're going through. And yeah, I'll show you every single step, and if you follow along, you will get the same thing at the end that I've got At least you should. But let's just take our time with this one. Let's not rush. So here I am installing the motors, and you might think, well, how much is there to say about installing the motors? The main thing that I pay attention to when I'm installing the motors is the length of the motor screws. The screws that come with the motors are sized for a certain thickness of carbon. And if you have a 3mm carbon plate, but the screws are sized for 5mm, they can be too long. And what you're going to want to be careful about here is that the screws do not touch the motor windings. Definitely check them as you're screwing them in. Generally, I like to see the screws be flush with or slightly below the level of the motor base. If they protrude slightly above the motor base, that's okay, maybe a 0.5 millimeter. But if they get anywhere close to the metal windings, they can destroy the motor. No kidding. They'll scrape the enamel off those windings and destroy it. So definitely check the length of the motor screws and make sure they're going to work for you. Here I'm using the button head screws that came with the JB motors. I do not actually prefer these for motors, and in fact I went back to the manufacturer and requested that for future builds we include cap head screws. This is just something that I overlooked when we did the first run. Cap head screws they take a 2.5mm driver instead of a 2mm driver, and they're just way more durable and robust. If they get caked with mud, they're easier to clean out, and they're way harder to strip. Here you'll see me using button head screws because I just didn't have enough cap head screws in my little screw assortment that I've got there to finish the build. Next, I'm going to install the CLRacing race wire / LED wire on the arms. I'm using Scotch Extreme Outdoor Mounting Tape, the black rubbery mounting tape, to mount them on there. That will also help keep them electrically isolated from the arms. Now I'm tinning the pads, and I do love that CLRacing has staggered pads similar to my PCB wire product. That was the big improvement that I made over Kelvin Lee's original race wire, which was to stagger the pads so they were less likely to bridge. Mine, however, does not have awesome LEDs on there, and now that I have seen these awesome LEDs, I love them. And it's a few bucks more, but yeah, I will be buying these from now on. Tinning is super important. Soldering skills are super important when going into a build like this. When you're tinning a pad, you kind of want to fill the pad with solder. Some people say I tin a little too heavily. I shouldn't have giant blobs of solder on my tin pads like I do. The reason I do that is because I don't want to have to feed extra solder in when I complete the joint. So I try to put enough solder on the pads and the wire that then when I go to make the joint, I only have two hands. So one hand's holding the wire, one hand's holding the iron, and that's where all the solder comes from. So I tin a little heavier than some people might. When cutting the wires to length, I always give myself just a couple extra millimeters. Cutting with a flush cutter so I can be very precise about where I cut them. And I cut them just a couple millimeters after the pad. I always like to leave myself a little bit of slack in case I strip the wire back too far or something like that. You cut it too long, it'll have a little wiggle in it, but if you cut it too short, you are out of luck. So you can see me here cutting them with just a couple millimeters past the pad. Next, I'm going to strip the wires, and I do use my diagonal cutters for stripping the wires. I don't have a fancy wire cutter. My goal is to strip back about 2 millimeters of insulation. A little less is fine, a little more is probably wasteful. If you have a fancy wire cutters, it gets a little easier to do it precisely. Having stripped the wires, the next thing to do is to twist the individual strands together so that they're all one nice tight bundle. This is actually really hard to do with a short wire like this. Normally I would pinch the loose strands and then twist the wire itself. Here I'm having to sort of twist the strands, and it's kind of hard to do, but you don't want any sort of splayed out strands of wire. You want them nicely twisted into a bundle before you tin. Then we tin the wire here. A critical step that some beginners overlook. My iron is usually at about 750 degrees Fahrenheit. That's hotter than some experts prefer to run. You can run cooler, but I find I get good results at about 750 for general purpose work. We want to just heat the wire and fill the end of the wire up with solder so it's one solid, smooth, silver, shiny unit. You don't want to be, oh, there's a little blob there. There's too much. Go back and get that, Joshua. Oh, well. Oh, there you go. You got it. Yeah, there was a little too much solder there. The tool that I like to use to actually perform the soldering is, it might be called a hemostat. Maybe it's a forceps. There's a difference between them, but I don't know what it is. It's one of these little medical pliers, and it's fantastic because unlike a tweezers, you can really grip the wire and control the direction of the wire, whereas with a tweezers, it's a little hard to get that extra little bit of grip on it. I'm going to hold them together and apply heat until, you couldn't see that one, apply heat until the whole joint flows together in one solid piece. You don't want to squish the wire or spread the wire. You just want to heat it and let the flow together into one smooth silver joint. If you finish and your joint is dull gray, if it's not a smooth surface, it means something probably went wrong. And the single best thing you can do to fix that is to get some flux, some liquid flux, put it on the joint and reflow the joint. That'll usually fix. The solder that I like to use is either 6040 alloy or 6337 alloy rosin core leaded solder. Kester is the brand that I typically use, but you don't have to use Kester. Any 6040 or 6337 leaded rosin core solder should do you pretty good. The reason I use leaded solder is that it flows way easier than lead-free solder. Some people are a little worried about using leaded solder. Don't worry, unless you eat it, you will not get lead exposure. It is safe to use. Just don't eat it. If you're a little concerned about putting lead in the environment, well, how many quadcopters are you really going to build in your life? How many spools of lead are you going to go through? Lead-free solder matters most for big manufacturers making millions of televisions and whatnot. Leaded solder is a lot easier for especially beginners and hobbyists to use, and I recommend it. In order to mount the flight control stack, I'm going to take a single M3 screw. This one is 12 millimeters long, and I'm going to pass it up through the stack with spacers separating the flight controller and the ESC. Here you can see me installing just a regular M3 nut. This will give just enough spacing between the ESC and the bottom plate that the ESC doesn't rub on the bottom plate, and it'll also hold the screws in place while I'm working with the frame before I get all the boards installed. Using a single long screw through the flight control stack is just one way of doing it. And in fact, in the past, I've talked about the things I don't like about this method. What I don't like about this method is that it's more likely to transmit shock and vibration to the electronics and potentially more likely to damage them. If you've ever had a crash with nylon standoffs where the nylon standoffs broke, then that is a case where maybe you would have broke your flight controller or your ESC instead. The other way of doing it, using a short screw and then nylon male to female standoffs, that is less likely to break the electronics, but if you ever break one of those standoffs, then you're going to have sort of the flight controller flopping around, and that's a problem of its own. So in this case, I'm using a single screw up through the stack for a little bit stronger, and we'll hope it doesn't hurt my electronics. As I'm installing these screws, you can see I'm leaving them slightly loose, and the reason I'm doing that is if you tighten them all down and they're not perfectly perpendicular, then it can be hard to slide the boards down. See, I'm wiggling it slightly loose. It can be hard to slide the boards down onto them, so I'll tighten them up afterwards. Now I place the ESC onto the mounting screws, and on the Armatan Chameleon and Rooster frames, I like to do it with the XT60 facing forward. This is also how Armatan does it, for what it's worth. This, you'll see later how this makes it easier to run the XT60 to the battery. I'm going to install some threaded M3 spacers here just to hold the ESC in place. These are either 5 or 6 millimeter height, and that's enough height to give spacing between the flight controller and the ESC without wasted space. It also gives some room to run wires if you prefer to do it that way. You might could go a little bit smaller, but you definitely do not want to have any possibility of the boards coming into contact with each other. You can get electrical shorts that way, or you can just damage the boards in an impact. So 5 millimeters, I think, is the optimal spacing here for this kind of ESC and flight controller. Now I'm going to start tinning the motor pads, and that's tinning all right. Just tinning these pads. Oh boy, soldering. I'm also going to tin the XT60 pads, and especially on the negative XT60 pad, you may need to crank your iron up because those things can usually take a lot of heat. I usually just set it to max 850 degrees, even though I know you could do it with a lower temperature if you had a heavier tip, but I just hit 850 and go. Because I'm using the CLRacing LED strips on the arms, I'm going to need an extra section of wire to connect the ESC to the motors. And here I'm tinning the cutoff lengths of motor wire that would probably get thrown out anyway. Well, some people save them. In this case, you can reuse those and they're perfect for the application. And we'll put some flux on the pads, just as some good insurance against getting good joints. Rosin core solder already has flux in it, but a little bit of extra flux never hurts. In the past, I've said, oh, I don't bother with it, but lately when I'm making joints for YouTube and want them to be as good as possible, I cheat and use flux. It's not cheating, it's just good technique. And we'll solder down the spare motor wires to the ESC side of the CLRacing LED wire. You've already seen me do this one time for the motor wire, so I'm not going to show it to you again. And here I'm going to begin cutting the ESC side of the wire to length. Again, I like to give myself a little bit of slack. It's easy to tuck that up inside somewhere if I need to. And I like to wire them straight through, just left to right, 1, 2, 3 on the motor pads. And then if I need to reverse a motor direction, I'll do that afterwards in BL Heli Suite. In software, I'm not going to do it by reversing wires because I just like to have the wires run straight through and be relatively neat. I'm using the same technique here that I did when I cut the motor wires. Cut the wire about 2 or maybe 3 millimeters extra length more than you think you need. Then strip off about 2 millimeters of insulation, twist together, tin, and complete the joint. The motor pads do have holes in them for the wires to go through, but you can see here that I prefer to put the wires on top of the pads. I find that the joint is just as secure if done properly, and it's a lot easier to do rework, and it's a lot less of a hassle to try and sort of push the wire through that hole. This just seems to go faster for me and is just as secure. So that's what I like to do. Definitely make sure you have good solder Oh, extra blob. Get that blob, Joshua. Oh, that little ice cream cone tip means there's not enough flux. That's not, oh, that is, get some flux in there, Joshua. Oh, I'm going to go for it though, aren't I? Am I going to put flux on? Or am I going to do it right? Okay, now I'm trimming into length. This tip is a little too long. No, I did not add flux. Let's see how this joint comes out. Is it going to be okay? It's not the worst I ever saw. For the main XT60 power leads, you're going to see me using 14 gauge wire, and some people are going to object to this and say that 12 gauge would be superior. Well, I've done some tests and show that it is not actually that much of a difference. In fact, it's almost no difference whatsoever between 12 and 14 gauge. And the reason is that the length of the wire is very, very short, only a few centimeters. So it really doesn't matter. The lost, it's like 15 watts total lost power in a 6 centimeter length of wire between 14 and 12 gauge. So 12 gauge is just that much harder to work with. 14 gauge is a lot easier to get into the XT60, and it's a lot easier to solder the pad. 14 gauge is, I think, more than adequate for any 5-inch mini quad. On a bigger joint like this, I'm definitely running my iron at max temperature, 850 degrees Fahrenheit. I like to think about how the wires are going to run. For the Rooster and Chameleon frames, I like to run the wires out the side. So you can see me sort of lining the wire up, going out the side. And I'm just going to hold the heat on the joint and try and touch both the wire and the pad together until it all flows and becomes liquid all at once. I think that's the thing a lot of people do is they rush and they don't let the whole joint become liquid. You can really see it happen on this joint. Although you see me struggling here to kind of figure out the exact angle that I want the wire to come off the pad. I want to make sure that there's no chance that the negative wire could accidentally bridge to the positive pad somehow. So I want to make sure it's not overlapping there and just get it at just the right angle inside these forceps so I can get it. I don't want it to go over the top of the positive pad. I want it to come out the side just like this. And I'm just going to keep holding things in place. I'm actually bracing the forceps against the positive pad, which definitely helps everything stay steady. Now you can see that the whole joint has not flowed here. It's sort of still separate and distinct, the wire from the pad. I'm coming back in and I'm going to heat it, and I'm going to try and heat both the pad and the wire. There we go. Now they have become completely liquid, and you can see it's all sort of flowed together into one smooth, shiny surface. Now we'll install the flight controller, and it couldn't be simpler. Thankfully, the Kakute flight controller has a compatible 4-in-1 ESC pinout with the JB ESC, so I can just plug them in. There's no fussing around with making a custom wire header. They'll just plug right in. And what I like to do is just give it some twists to take up the slack. You don't want tension, but you definitely want to take up the slack, and then figure out which way is forward and There you go, Joshua. Go ahead and just go ahead and install this on top of the standoffs. Make sure when you're putting the flight controller down that you don't pinch the wires in any way. I like to run the wires underneath because it keeps them out of the way and leaves me room for soldering. But yeah, go ahead and press that down, make sure it doesn't pinch. And I'm also going to go back through and I'm going to kind of make sure that now that the flight controller is on top, remember I kept those standoff screws loose? Here, we'll get a closer look for you. I'm going to sort of pinch the ESC down so it binds the M3 nut. And now is the time when I'm going to tighten up those stack screws and get the last little bit of slack out of there now that the flight controller's on there and I don't need that little bit of wiggle to help it get on there more easily. I'm also going to come back in here with my hemostat or forceps, I don't know which it is, and tighten down this spacer so that it's holding the ESC securely. There you go. I like to tighten everything down after everything is on the stack because, again, if the screws are not perfectly perpendicular, and they seldom are, getting a board on can be really tricky. You can have to really jam it down there, and it feels like I'm putting a lot of stress on the flight controller if I tighten the screws down early in the process. At this point in the build, I usually do not put the M3 nylon screws on top of the flight controller because if I do, I will melt them with my soldering iron as I'm soldering it up. But for the Kakute, these two screws on the right side are well away from any soldering, so I'm going to go ahead and put these screws on and tighten them down to hold it in place while I'm working with the board. And I'm no risk of melting them with a soldering iron because all the soldering is going to be on the left side of the board. For installing the XT60 connector, the process of preparing the wires is the same as you did when you soldered them to the flight controller. Strip, get a good hot iron, tin the crap out of them to get it full of solder, and then install the XT60. I'm using an XT60 that has a plastic shroud, so remember to install that on the wires before you solder on the XT60. I've forgotten that many times, but this time I remembered. I'm going to get just a little bit of solder inside the cups of the XT60 connector itself. And I like to turn those cups sideways so they face up, and you can see me using my handy dandy hemostat there, or forceps, I don't know which it is, to hold it in place while I work with it. I'm now cutting them to length. I just want maybe 3 millimeters of length. That doesn't need to be exceptionally long to go into those pins. And here I am going to just apply heat until that, get in there, buddy. Until that wire begins to melt. Just want everything to become liquid and then come together. I am holding the XT60 with the hemostat, not with my bare fingers because it does get pretty freaking hot, but there you go. And now we're going to do the same thing with the negative wire. One mistake people make is applying too much pressure with the iron tip, and that causes the joint to sort of splay out and spread out. Just make contact, wait till the heat makes the joint liquid, and come together. Yay, we have motors, we have flight controller, we have ESCs, and this is the part where I take the quad over to the computer and I use the Betaflight motor test function. I use the motors tab to test that all 4 of the motors spin, and don't worry about motor direction or anything, but just make sure that you don't have a smoked ESC or something dumb like that. Also, isn't that race wire cool? The next thing I'm doing is I'm mounting the real pit board using a piece of VHB, very high bond tape. This is a really good tape for this kind of application. I'm mounting it to the top of the flight controller in an inconspicuous location. Make sure when you mount it that it is not touching in any way, interfering with the gyro circuit board, which is mounted on a piece of foam tape. You can see where I've put it. The real pit is used to switch the video transmitter on and off. Literally, you power it down using an aux mode and a switch on your transmitter. And this is really nice because it lets you plug in your battery at an event without any chance that you're going to accidentally knock somebody out of the air. It's nice because it lets you turn your video transmitter off if you crash, or if you don't want to have it overheat for some reason. You can easily switch it on and off. It's better than pit mode. It's more reliable than pit mode for sure. And I want it on every build that I do forever. The factory wire harness from the Unify comes with a plug you can easily plug into a little 2-cell battery. And I'm going to unlock it here. Hold down the button until you see the blue light come on once. Then this is the second time, 1, 2. And then hold it down until the blue light comes on, and keep holding it down for like 30 seconds. And that will unlock the Unify and let you access the higher output powers above 25 milliwatts and all of the channels. Yep, this is real time. This is how long you got to hold it down. Just keep holding it down, and eventually that blue light will go out. So again, the sequence that you want is press the button until the blue light comes on one time, then do it again, then do it for 30 seconds, and then do it one more time to exit the setup mode. And now the Unify is unlocked. If you need to, go back and watch the video and you can see it happen again. Now I'm going to remove some wires from this header because I'm not using all of them. The one I'm going to remove is the green audio wire because I don't fly with a microphone. If you fly with a microphone, it would get hooked up to this audio wire. And then I'm also going to remove the 5-volt output and the extra ground wire, which are designed for if you were using the Unify on like a fixed wing where you didn't have a flight controller. This would be where you'd plug the camera in. Power from the camera would come from the Unify. I'm not using that, so I'm going to remove the orange and the adjacent black wire. I'm also going to cut off this JST connector. I don't remember the name of it, but obviously we're going to direct solder the flight controller. The Unify is going to get power from the B+, that's the upper rightmost pad on the Kakute, that's VBAT, and I'm just using the spare orange wire that I cut out of the Unify's header for the camera 5-volt out. I'm going to use that to run power to the real pit. The technique that I like to use when soldering to these through holes is to just tin the pad and then sort of let it flow and kind of stick the wire down through and let it solidify around it. The traditional way of soldering through holes is to stick the wire through and solder from the backside, but you can obviously see why that would be not really very feasible in a situation like this. And we're going to do ground, and again I'm using the spare wire that I removed from the Unify's wire harness. And just to keep things neat, I'm going to give these guys some twists. I always like to twist my wires to kind of keep them neat. And let's see where these are going to go. They're going over to the real pit. Next we'll do video, which goes to the VO pad, video out, which is just below the B+ pad, as you can see here. And we'll solder a yellow wire there. The white wire from the Unify plug harness is going to go to a UART for smart audio. You can see me sort of feeding it up through and twisting it around here. I'm not sure if there might be an easier way to do this to keep it just, yeah, you just got to solder and twist and just make everything nice. Now I'm going to use T1 here for smart audio UART1 transmit. That's where the white wire is going to go. It's a little confusing on the Kakute because the labels are to the lower left of the pad that they're labeling. So there might be some confusion as to which one T1 is. T1 is to the upper right of the label T1. And you can see here I've failed to push the wire through, so I just solder it on top. Who cares? It's not a big deal. It'll be fine. Just pull everything snug here. Oh, very nice. Very nice. What I'm doing here is twisting together the two ground wires. The one coming from the Kakute ground, which is just to the left of B+, and the one going to the Unify. Both the real pit and the Unify need to have ground, so we're going to twist these wires together and then solder them to the real pit. Yeah, hopefully that makes sense. Now what you see me about to do here is a very advanced move. Soldering over the board like this, if you do this, be careful not to drop a blob of solder on your flight controller or burn that ribbon cable with your soldering iron. I've done it. So just put something down to protect it if you really need to. So now we got these two ground wires twisted together, and get your head out of the way, Joshua. Figure out where it needs to go. Oh, but wait. You see, I've just figured out that I'm going to need to solder to this flight controller signal pad, and if I do that after I do the grounds are going to be in the way. So I'm going to do this one first. Again, I'm just using a spare wire, one of the wires that I cut out of the Unifier's wire harness. This green wire is going to go from the FC pad on the real pit to the M5 motor 5 pad on the Kakute. But real quick, we're going to finish up this ground joint right here. And the red wire from the Unify to the VTX Plus pad on the real pit. Good, perfect. And here is the Unify wire harness and plug wired up to the real pit. Just give it some twists to keep everything neat. We still have one more connection to do on the real pit, which is the signal wire, the green signal wire to M5. We haven't done that yet. Just figuring out how tight I want that. And there we go. Green wire from the FC pad on the reel pit to motor 5 M5 on the Kakute. Crossfire Nano receiver. It's been tinned, and I'm going to solder on the wires. Ground, 5 volts, IO1, and IO2. IO1 is the TX and IO2 is the RX for the Crossfire communication. Make a note of the color wires you use there so you don't have to go back and wonder later. And some of you are going to ask, what is that blue stuff you're using? That is called Fun Tack. It is mounting putty, and it's very useful for soldering as well. You can see me here. I'm going back to clean up some of these joints. See, you weren't supposed to see that. You were supposed to think I got it perfect the first time. But I didn't like some of these joints, so I'm going back to clean them up and just reflow them just slightly. Now I've installed the antenna, and what I like to do is fold the antenna back across the body of the receiver. Make sure, you see it's not quite straight back. Don't get it jammed so it's going to want to pop off against some little chip or component, and definitely don't cover up the LEDs or the bind button. But I like to fold it back over, and then this stuff that you see me using is called Kapton tape, K-A-P-T-O-N. There's a link to it on my Ultimate FPV shopping list in the supplies section. I like to use that instead of heat shrink because I just find it easier to apply. It's thinner than heat shrink, and it's just easy to use. I just like Kapton tape. So you can see by folding the antenna back over the body of the receiver, it helps keep that UFL just a little more secure. Of course, if I have to change the antenna, then it's going to be annoying. I'm going to have to cut this stuff off, but that's the way I like to do it. For soldering up the Crossfire receiver, we're going to use these pads, ground, lower left, 5 volts, diagonally up and to the right from there, and then UART 4, RX, and TX. Ground. Five volts. It might have been smarter to do these top down. I don't know. Either way. Ground, 5 volts. TX. And make sure that goes to the RX pad on the Crossfire receiver. So that's going to be IO2, the last one near the edge. RX goes to TX, and TX goes to RX. And here goes the RX, which goes to TX on the Crossfire. See? Yeah, make sure you get that right. And we'll give the Crossfire receiver some twists to take up the slack in its wires as well. Next, I install the back standoffs on the Chameleon Ti frame, and that's to help me know where the Unify and the receiver can go without getting in the way. The way I like to mount the Unify is to place just a little thin piece of VHB very high bond tape on this cross piece, and then put the Unify down on top of it. And the Crossfire receiver is on top of the Unify, again with a piece of VHB tape holding it down. Now, such a tiny piece of VHB tape, as strong as VHB is, it's not going to hold the Unify down to the plate all by itself. But what I like to do is put some zip ties around the frame to hold the receiver and the Unify down, and then the VHB tape keeps them from sliding around much in an impact. The zip tie is really holding it on. The VHB keeps it from sliding around. Obsessively neatening the wires. Here's a closer look at how I've got this mounted from a different build I did, showing pretty much the same thing, but just shows how it sort of all goes together. And notice as I'm installing the zip tie, I'm going to be really careful not to press any of the buttons on the Unify or on the receiver. Just make sure that it doesn't run over that bind button or anything. Well, I'll probably squeeze that out of the way after I'm done. You don't want it to accidentally press a button. And, oh, it's right on top of the button. Good job, Joshua. Way to demonstrate your point. Don't do that. Notice also how the zip tie is holding the antenna down, so it helps keep the antenna a little bit secure as well. And then a couple of zip ties here just to go around them and hold everything down. And make sure when you do this that you're not accidentally covering up or pressing on the button of either the Crossfire receiver or the Unify. Now I'm going to plug in a battery, and it is a great idea to use a smoke stopper if you have one. It's also a great idea to check with a multimeter to see if you have any continuity or any problems. When you plug in, you have 1 minute from the moment you apply power to press the bind button on the Crossfire receiver, and it will enter binding mode. On the Tyrannus, I'm going to long press menu, then page, down to Crossfire, crossfire.lua, enter and execute to run the Crossfire Lua script, and then press enter to go to the Crossfire Micro TX and enter binding mode. If you have the full-size Crossfire module, you can do all of that from the menu of the module with the little joystick, much easier. The module will then bind with the receiver, assuming you already put the receiver into binding mode. If not, go ahead and do that. And it'll probably need a firmware update. The Crossfire module will ask if you want to update the receiver. You can go ahead and do that. When that's done, the receiver should reboot and everything should be good. You should have a green light indicating that it's bound. After the update is finished, the next thing we'll do is back out and go to XF Nano RX, and this will let us configure the receiver. And the default configuration on the receiver is right in almost every way, but the main thing you want to change is change the failsafe mode from FS pause to cut. This is essential. The other thing I like to change is in the output map, I want to change, there we go. Where's the channels? There they are. I want to change channel 7. Where's channel 7? There you are. Hello. I want to change channel 7 to LQ. This causes the Crossfire receiver to output link quality on channel 7 and makes it easy for you to put that into the Betaflight OSD. Those are the two changes I make for all my Crossfire receivers. This is the RunCam camera control adapter board. It is inside the box with the JB Micro Eagle, and it's going to let us control the joystick, control the OSD menu on the Micro Eagle using our transmitter sticks. Here's how we wire it up. First, solder on this little plug that comes with the board, and it's going to plug into the back of the camera where the joystick would normally plug in. The labels for the pads are on the underside of the camera control adapter, so if you're not 100% sure, just flip it over and double check that you're soldering correctly. The black one goes to ground, and the blue one goes to the other one, to camera, whatever they call it, signal, camera control, I don't know. Now we'll solder on these wires. They come with the camera control adapter board, so we may as well use them. Red one is for 5 volts, black one is for ground, and then we've got a green and a brown wire that we're going to use for TX and RX going to the UARTs. Now I've used a piece of the VHB very high bond tape, the same stuff I used on the VTX and the receiver, to stick the camera control adapter board to the back of the camera. This bracket allows the camera to mount on the full-size mount on the Chameleon front end. It's not made for a micro camera. Really looking forward to the Armatan Marmot frame, which is sized for micro cameras and won't need this. We'll go ahead and insert the camera into the bracket from the front, and then 2 of the little M2 screws that come with the bracket hold the camera in. Here we go. Oh, they're M2, yeah. Well, it's a 2mm driver, so that makes you think it would be an M3 screw, but no, I'm pretty sure they're M2 screws. They just have a 2mm head. Anyway, they come, you figure it out. You'll figure it out. Now I'm going to plug in the regular camera cable that comes with the camera, the one with the red, black, and yellow wire. The Kakute has a 5-volt header for the camera right here in the upper left corner, and that's what we're going to be using. It's especially convenient to use this because the camera control adapter board also requires 5 volts power. So if we power the camera off 5 volts, we can easily power the camera control adapter board from the same header. A lot of times I prefer to power my cameras off of VBAT, but in this case, the 5-volt regulator from the Kakute seems really solid, and I haven't had any problems with this so far. I'm also going to tin T3 and R3, which we're going to use for the camera control function. Power, ground, and video from the camera are going to go to that 5-volt header. So now I'm twisting these wires together. There's 2 power and 2 ground, one from the camera and one from the camera control adapter board. I'm leaving the orange and the green wire out separately because they're going to be cut to a different length because they're going to the UART. Unfortunately, I haven't done a great job of showing this on camera, but I have twisted the 2 power wires and the 2 ground wires from the camera and the camera control adapter board. I've twisted them together so I can easily solder them to the same place. Now the orange and the green wires come, and one of those is going to go to TX and one's going to go to RX, but I can't remember which I soldered up. Make sure you do this right. Remember, TX on the flight controller goes to RX on the peripheral. If you soldered yours up exactly like mine in the previous step, then you can follow along here, and orange will go to TX and green will go to RX. But just double check that. Well, it'd be hard for you to double check it if you've already stuck it down to the back of the camera. So let's just hope you follow along exactly right. There we go. Now the camera is all, and I'm just going to do what I love to do and give it some twists to make sure that's stuck on there. Good. Yeah, good. Guess what? That is almost the entire quadcopter right there. You could almost fly this thing if you had props on it. Now we're going to complete assembly of the frame, and I actually have a really detailed build video that I did for Armatan showing how to put the Chameleon Ti together. So I'm going to show you the steps here, but if you're having any trouble figuring it out, like exactly which screw did I use, I'm going to let you go ahead and go over to that video. I think most people who've gotten this far can probably figure out how to piece together the Chameleon Ti. So this little bracket piece goes on the front of the Chameleon Ti, then one of your metal front end side pieces goes on, and the screw goes up through the bottom. These are, I don't know the exact length of these screws, but they're some of the longest screws, maybe the longest screws in the kit. Getting all this to line up is a little bit tricky, but you know, just fiddle with it till it goes. I suggest that you do not tighten this screw all the way down when you're installing the camera and the front stand-up. When you're installing the camera and the front stand-off, it helps to have the front end just a little bit loose. After I've got the two front side pieces on, the next thing I like to do is install the camera. This is going to be done with the little M2 screws that come with the Chameleon. You're going to need to use those, not the screws that came with the camera, because the ones that came with the camera are not long enough. Again, leave these screws loose until you have put in the front standoff. If you tighten these down too tight, then you won't have enough slop to get the standoff in. So just leave these a little bit loose. I'm going to put 4 of these in, 2 of them that hold the camera and 2 of them that set the angle. And pay close attention to which of the mounting holes on the camera I'm using. Some people mount it using the bottom one, and then there's nothing to hold the angle. It just flops around. Now we'll do that M3 standoff. I like to use the longer screws than they actually call for, because I feel like having a little bit of extra screw length in the standoff actually helps strengthen it. There's usually a couple extra long screws in the kit that I go ahead and just grab. I've never been unable to finish a build based on this, but anyway, that's what I like to do. This standoff is, I think it's 28.5 millimeters. It's got to be the width of the camera, which is 28.5 millimeters, which means that if you lose or break it and you need a spare, you actually can't easily just go to your favorite site and just order a generic standoff. You have to order a specific 28.5 millimeter standoff for this frame. Fortunately, sites like Race Day Quads, you could probably find them. If you're in the US, you should have no problem finding spares. But if you think you're just going to grab a standard 28 millimeter standoff out of an assortment, then you're not going to. It won't work. Here you can see me tightening down the camera screws after I set the angle of the camera to where I usually like it. We'll tighten these screws down. Don't go crazy cranking them down, because I mean, they're just M2s. You could strip them. Now I'm going to install the top plate, and I know you're going to ask, so I'll tell you, this session mount is from Brain 3D. They make, I think, some of the best 3D printed parts you can get, and I love this session mount. It just slips right over the little carbon fiber plate and holds the session really well. They also make a GoPro, regular GoPro version of the same thing, I believe. I know they got mounts for any kind of GoPro that you want for this frame. I'll put a link to this down in the video description with all the other gear that I'm using. One thing about it is it's a little hard to get the screws in at the right angle, so I just kind of, hey, it's TPU, just bend it out of the way so the screwdriver can go in straight. I know that sounds obvious, but the first time I installed one of these, I didn't do it, and I inserted the screwdriver at an angle and like half stripped the screw, and it was a real pain. And I was like, duh, just bend the TPU, Joshua. It'll be fine. Now, the Chameleon comes with a really cool mounting system for the FPV antenna and the receiver antennas, but I don't actually like to use it. Here's how I like to mount my antenna. The first thing I do is I'm going to wrap the SMA connector with some electrical tape. The reason I do this is that sometimes, not always, but sometimes you get video noise caused by grounding issues caused by the SMA connector touching the frame. So you don't have to do this. It does look a little bit sloppy. If you were really concerned, you could use like liquid electrical tape or something. But then, of course, if you have to change your antenna, that's going to be a little bit messy. So I just use electrical tape and bite the bullet on how sloppy it looks. Well, I mean, I try, but... And the way I mount it is with a couple of little zip ties in an X-shaped configuration around this standoff. The X shape helps keep the tension from pulling the antenna one direction or the other. And I find that doing this, it gives just enough strength that the antenna stays in place, but it's not so rigid that the antenna can't move and take a hit. And I think this is really just minimizes the damage that can occur to the antenna. In a really hard hit, I guess the zip tie might break, and that's actually not so bad because, I mean, the antenna is usually still held on by one zip tie, the other one's loose. Sometimes it gets in the props, but overall, this is how I really prefer to mount my antennas on the Chameleon frame. Anyway, that's what works for me. You can go with the standard way they do it if you'd like, but I just don't like that grommet that they use and the way it all clamps down. It just seems to not be as reliable for me. So here's how it all ends up when you're done. And see, it's pretty secure, I think. No stress on the SMA connector. And notice that none of the metal from the SMA connector is touching the standoff either. For the Crossfire receiver, I actually prefer to use the standard antenna, the whip style antenna, the coax antenna, more than the Immortal Ti. The Immortal Ti is more durable in some ways, but then once it gets whacked and bent up, it just falls apart, unravels, and it's just really ugly and nasty. I feel like using the coaxial whip style antenna is more durable because it's easy for it to sort of bend out of the way and bounce back. And the way I like to mount it is with two zip ties on the rear standoff in a V configuration. You got to be real careful about the angle of these because not for RF reasons. Yes, the angle does matter for RF, but if you're not careful about this, they will get into the props and then they can get chopped up. So you want to kind of set the angle so it's not too close to the motors and close to a 90-degree V, but anyway, you just kind of do your best. I find that even when this antenna takes a little bit of damage, at the typical ranges that I fly, you're just 98% LQ all the time, and so there you go. If you're going for ultimate long range, this is not the way to do it. This is not ideal. But for me, I find for freestyle durability and also ease of portability, having the antennas be flat versus vertical, it's easier to just toss this in a backpack or something without banging up the antenna. So here I've got a length of 3/32 heat shrink. I have just a big 50-foot roll of this stuff. I use so much of it. And it's just going to go over the zip tie and over the antenna and hold the antenna wire down. Now, one of the mistakes I'm making here, and I didn't know this was a mistake at the time, is there are two pieces of the Crossfire antenna, that little black piece and this little coax piece, and the coax piece is actually longer. I would suggest that you do the coax piece away from the motor, whereas here it's going toward the motor and it makes it more likely to get into the motor by accident. I would do the black piece on this side toward the motor and the coax piece on the other side going toward the center line of the quad, so it's just a little further away from the motors. I'm just going to get this all stuffed up in here and then shrink it down. And the same with the other piece. Same deal, just heat shrink to the zip tie. Now it's always important to have strain relief on your XT60, otherwise when you eject a battery, it'll tug on the solder pads and eventually it'll rip them off. So I like to do that using a zip tie to this back part of the front end. Just put that zip tie on there. Make sure that you route that cable such that it's not going to get into the prop in any way, but this is the way I think is really the best way to do it. And that pretty much brings us to the end of this build. Okay, I put the top plate on and I haven't put the Emma grip on yet, but I think you can figure that out. One thing that you see me doing here is I'm adding some conformal coating, some silicone conformal coating to the solder joints of the ESC wires and to the ESC joints itself where the wires go onto the ESC. This is for waterproofing protection, protects against corrosion and short circuits due to moisture. Thank you guys so much for sticking with me on this build. If you have followed along in this build, I am going to put a link to my Betaflight 3.5 configuration file. So if you have the exact same setup as me, you can just copy that config and you can get everything ready to go. You should know that I have some pretty weird flight modes. Check out my video, all flight modes on one channel. So you may have to set up your own flight modes, but all the other configuration would be fine. I want to remind you that there are affiliate links to all of this stuff down in the video description, and it really helps me out a lot if you use those. Or if you decide to join up as a patron, I would sure love that as well. That's it. I got no more video. Thanks for watching. Happy flying.